We'll start now. Okay, welcome to Nested Loops. This is the first session for Design Patterns 2 Explained, of which I brought my trusty first edition when I bought paper books, which, by the way, is handy, and I can put sticky notes in and whatnot. So, of course, Al has graciously offered to give a little intro to his own book here. So we'll have him start shortly. What was I going to say? I think a little preface this book. So I picked this book in particular for the second book of our group because it's the book that I think really edged me in far as understanding how and why design patterns work and the way that I do most of my other development or any kind of technical stuff is I really appreciate the principle-based approach. Whereas if you understand how and why things work, then you have a general knowledge, problem-solving ability, as opposed to just memorizing and learning things, which of course is naturally your first step in learning anything. And it's much harder, I think, to acquire the level, but it always pays off. And this book in particular, I think, was really key into helping me understand design patterns at a conceptual, principle-based level. And another book that I think we might address too is Refactoring the Patterns by Josh Karyevsky also. But anyways, I'll let Alan pick up with his introduction, and then I'll start. I'll probably be able to cover Preface and the first chapter, given when I reviewed it last night. So that's what we'll shoot for. So Al, take it away.
Yeah, great. So, yeah, I'm kind of glad to be here. I thought I'm just going to be here for this beginning part because I actually got a busy schedule today, but I thought it would be a good opportunity to explain some of the metamorphosis of patterns. And as you prepare for studying, it'll give you some insight. So I started using patterns in '96, and a book I would read concurrently with my book, and the second edition is not just an update, it's almost like an entirely new book, just to be clear, and I'll explain that in a minute, is Christopher Alexander's Timeless Way of Building. Everybody recommends his pattern language, but that's because the pattern language is an emphasis on patterns as patterns. But in the Timeless Way of Building, which is the book that led to my insight on what patterns really were, at the end of the book, on like 545, I think page 545, it says, at this point, you realize the patterns aren't important. The patterns have taught you to be receptive to what's real. And by the time you read that phrase, you know that already. I remember when I read that, it was like, yeah, I know, patterns aren't important. What's important is the way the patterns bring the issues and the forces together to solve the problem that's at hand in the context it's in. But the patterns are like to a good cook. Patterns are like recipes. You don't really, good cooks don't need recipes because they understand what's going on. Recipes are a good way to learn how to be a good cook. I actually am a good cook, turns out. I learned from recipes, but at one point it hit me what all the recipes were doing and what the flavors were, and then I could just make up recipes now. They're not even a recipe. I just throw the stuff together. It looks like I'm throwing it together, but I'm not. I know what the issues are. I know what the flavors are. I know the difference between broiling and poaching and frying and pan frying and using it in a rotisserie. All those different things you eventually learn, and you just do. So patterns, the first edition was actually about that. That was the insight I got. I think it was in '97, after I'd been using them for a little bit, or I'd known them, but I wasn't able to use them. I found that I knew all these patterns and I couldn't use them until my insight with Alexander. And then it was the idea that patterns gave us insight into the problem domain. They were a way of looking at the forces, and that patterns had a way of applying them and using them and thinking about them. So the first book is really about using patterns as what we call patterns thinking. And it's different from the patterns themselves. And I actually do believe, I heard you mention Joshua's book. Joshua's really brilliant, and Joshua's book is really good. But I'm not sure he and I are in agreement on patterns. We haven't had a complete talk about it. We should. We know each other pretty well, but whatever reason, he and I have never talked about this. But my view is patterns. Well, I shouldn't have probably even gone there, but but there may be differences. You might find differences in the book, although I would read his book because he's a smart guy and it's a great book. In fact, somewhere I remember talking, I think when I talk about the bridge, I talk about how to refactor to the bridge pattern. And it's, again, if you follow this thought process, you will end up with patterns. In fact, I just realized, I think I have a seminar I'll send you because it may not be in the book, but it illustrates all this. Anyway, the second edition was the realization that patterns can be used in an agile environment in a very good way. I thought of this while we were writing the first, but we just had to stop writing and put it out there. So in the second edition, the thought, and I don't know why this is in the book, to be candid. I don't know I explain it this way. We talk about patterns are about hiding things, encapsulating things. Like the abstract factory is a factory that hides which objects I'm creating. The strategy is something that hides the algorithm. A decorator is something that hides whether or not you have alternative options. The composite is hiding whether you have one or many things. The iterator is hiding how you traverse a collection of things. It's all about encapsulation. But what we think about when we talk about encapsulating, we think about things or roles or stuff like that. But Agile brings another idea to it, and that is encapsulating things over time. And this is a very important concept, because when we talk about variation, that kind of sounds like we have what you do, you're developing software, you're familiar with that you can actually have variation in only one thing at any one time. In other words, you start with an idea and say, oh, I'm going to build this. And then you show it to a customer and they say, no, that's not what I meant. I wanted this. So you build this other thing. And then they start using it and they said, I like this, but I would like this better. And better is a key word because it means they don't keep the original one, they go to the next one. So there's this notion of variation over time that occurs. That's actually very important. And if you think about Agile as this, we're varying, we're learning as we go, and we're uncovering things as we go, we may end up only having one thing. And you therefore would think, well, then why do I even have a pattern? If I've got only one algorithm, why do I need to encapsulate the one algorithm? And the reason is because over time it might change. And I may not put in an abstract class at the beginning because, when the first time I have it, that could be overkill. But this is where things like encapsulating the constructor, which I sure hope is in the book. Like I said, I haven't looked at the book in a long time. But encapsulating construction is a key thing. And I'm pretty sure it was still, in fact, I should be looking while I'm talking. I have it up on my Kindle. I've got to talk about that. But again, you might look at the encapsulating construction chapter of Essential Skills, which is on our website and free. The idea is you hide things over time. So when you're looking at the book, the way to look at it, the way to look at patterns in my mind is that the domain of software development is very complex or complicated, actually. The actual building of software, to my mind, the doing of it is complicated. It's not complex. The people involvement makes the whole effort complex. And don't worry about it if you're not sure why I'm making that distinction. But for some of you who do know that, probably with a Kinefin, there's a lot of stuff in patterns, and it's hard to grok it all at once. So learning patterns as a set of, oh, here's how I hide this, or here's how I hide that, or here's how I set up hiding. Like an abstract factory does hide what I'm creating, but I'm doing it in support of the fact that I'm trying to hide which objects I'm using so I can vary them. So, I will talk about, in strategies in the bridge pattern, I don't want to know what the objects I'm using are. So we hide them with the abstract factory. But what you want to realize is that the patterns really are just examples of the thought process. There's nothing sacred about the strategy pattern or the decorator pattern or any of these patterns, or decorator pattern in the chain of responsibility, where you have a link of things that you go through and there are similarities. The thing is, these are just things we've named. And I don't agree that patterns have to be discovered 3 times. You can create the damn things. You create them by giving what are the forces I've got, what's the intention, and how does it work? And if you're following the principles and the qualities of code and making sure they're good, you've got just as good a pattern as anything else. Now, it may not be a very common pattern, but it's still useful, and now you've named it. I'll give an example. I remember early on, I was working with a guy when I was first learning patterns. So in the decorator pattern, that's where you have an object that you always do, and you have alternate ways to decorate it, where you might do some extra stuff before the main object. Like if you have if you have a translate object, you might have an optional decoder in front of it or not, depending on what you're doing. And then there's a chain of responsibility pattern, which is about, well, I've got this chain of objects and only one of them is supposed to work. Again, it might be a translator and it senses what language and then it translates it and then it, of course, stops going down the chain. So in the decorator pattern, you go through every step and you've got one main object with a few extra things optionally on it or not. And the chain of responsibility, you know you need to do one of them, but you're not sure which one you do. And when you do one, you stop. And I remember one guy said, well, I got like a chain of responsibility, but where everybody gets a shot at it. And it wasn't a decorator because there wasn't the main object, but it wasn't the chain of responsibility because everybody was doing their work on it. What was it? Well, it was a chain of responsibility where everybody got their shot at it. It's the important thing is you learn what the patterns are intended to do, what they're accomplishing. So a strategy, I have multiple algorithms, maybe at once or maybe over time, and it's a construct to solve it. Now, to handle that situation, now, is it a switch? Is it an abstract class? Is it object injection? I don't really care. That's an implementation issue of the pattern. So that's the other thing to remember. There's a pattern's intention. There are the forces the pattern is solving. And then most of the books worry about the implementation, rather, of the pattern. But the implementation is really the least important aspect. That's a language, usually a language specific thing. So anyway, just to sum up that ramble, and sorry, I did ramble a bit, is realize that patterns are thought process, or the best way to use them. The good metaphor is patterns are recipes, and patterns thinking is what a good cook does. He knows all the different issues and forces. He looks for those issues and forces and then uses patterns that are present or things that are similar to patterns that are known to be present, so you can mix and match, in a sense, the things. And this is where Joshua had the right idea too of refactoring to patterns. The difference is, what is the pattern? I'm not sure we totally agree on that. Most people think of patterns as these solutions. Why? Because Chris Alexander, in the same book I was quoting, also says patterns are solutions to recurring problems in a context, but he doesn't really think about them that way. He thinks about them that way at the start. That's again why page 545, end of the book, he says you discover patterns aren't important. It's what they've revealed to you is important. So when you're using and learning and studying from the book, keep that in mind. There's no dogma here. And it's been, I don't know, a long time since I wrote it. So if you have things that you are in question of, there are user groups I'm on. There's actually on our portal, there's something that's maybe just send me questions, and I'll send also some other places that might be some good support for y'all to use. We have a lot of information on our website. So portal.netobjectives.com is a place you might go look, but I'll send you some other information. So I'll answer any quick questions, and then I got to go, but I thought I'd chip that in. Hope that was useful.
Yeah, that's good. I can't speak to the second edition because we're studying it, but my quick summary on the book is the first edition, you talked about like kind of like techniques, like design patterns work by, isolating what changes from what doesn't change, etc. So you just, in general, how they work. And so when I looked at Josh's book, your analogy at the end of being the cook and having the recipes, but I'm not just remembering the recipes, but I kind of know, I know what makes a tart thing. I know what makes a spicy thing, which I learned from the recipe. So now I can throw together any dish. And Josh's book really talks about, okay, here's our problem, and this is what we want to. And sometimes this goes towards a pattern, sometimes it goes away to the pattern. And the key thing that he really pointed out there was, hey, if you solve your problem, you don't have to go all the way to the pattern.
Exactly. That's right.
And that's what made it insightful, because there's this idea that he reinforces with examples. Okay, we thought it was this, but we only had to do half of that pattern to solve our problem. So then we're done, because otherwise the rest of the code is unnecessary. We don't have to cookie cutter stamp the entire pattern because we've already solved the problem we wanted.
Yeah, we're totally in agreement on that aspect of it. The thing is that you're heading toward the pattern But the question is, what is the pattern? See, if you think of the pattern as the solution, then what he says makes total sense. And actually, I agree with it, whether you think of it as a solution or not, because you're saying I'm not taking patterns and putting them in. I'm rather taking things that are useful that the patterns illustrate and putting in just enough as I need to. I wrote an article called "Can Patterns Be Harmful?" And if you think of patterns as solutions, then they actually can be. And Joshua doesn't think of them as solutions. He thinks of them as examples. If he takes the value out of that example, then yes, totally agreed. You don't go toward the pattern. If you think about the patterns as a thought process, it gets a little different. So there's good in both areas. One other thing I would suggest, and I don't know, we wrote this book called Essential Skills for the Agile Developer a few years ago after the second edition. And we talk about practices. I'll find this reference and I'll give it to you. There's another aspect of patterns that I don't think we talked about in the book, even though I mention quite a few of them, which is some things you should just always do. You know, like I believe in encapsulating construction as a key practice. And by practice, I mean something really simple you can do that usually gets you value, but has virtually no cost to it. Like a doctor washing his hands before he sees you is a practice. If you study the patterns as you study them, you'll see there are some things that are kind of like little micro idioms almost that are quite useful that patterns might teach you. Or, oh, this would be a good thing to always know. Like it's a good idea to not have the object that's using something actually know where it came from, because if you have those two separate, then you can change which object to use. It's like why the strategy pattern, one of the concepts in a strategy pattern isn't just that I've got different strategies, but is that the person who's using, or the object that's using the strategy object, doesn't know where it came from. Even if it calls the factory that creates it, it doesn't have the rule. That's an important thing. And we talk about that in the book. But there are practices that the patterns become useful, that will illustrate why they're of value. So anyway, I'll do a little follow-up note because I should have it anyway. I'll just send you more of a link to some place for free, info on our website that'll be useful for y'all. And also there's an online course if you're interested, but you don't need to get to that. So anyway, I'm good. You guys good? Good luck with it.
Anyone want to ask a question before he takes off?
Yeah, please. Oh, yeah, you're asking. Yeah.
Anyone who's not me?
No, but that was good. Thank you.
Okay, very good. Good luck with all that.
All right, thanks for dropping in, Al.
You bet. Take care.
Okay, bye. All right. I will go and share my PDF thing, which is where I'm going to slide around. I guess I got to pull this one over here. Oh, that can be application. All right, here's my stuff. I wanted to actually cover the preface, and fortunately there was not a lot of overlap with his preface and my preface. So again, he wrote this book. It looks like 3 years afterwards, and it reminds me of Kent Beck rewrote Extreme Programming Explained 5 years after he wrote the first one, and he basically, I think, in the most awesome move ever, completely rewrote the book from first principles and based on his teaching experiences. So if you look at 1 and 2, there is like pretty much no overlap, right? Which is like very few people do that one. But anyways, I don't know that this is that, because obviously I haven't read it. But reading the preface, we should go with this. So he starts off with this chapter, and as you guys know, I already have the first edition. Should you buy the second edition if you already own the first? And he's got a bunch of stuff that you can read there, but you can see I highlighted over here. We have learned so much more about design patterns since, and he talks about some of the stuff that will be in the book. I highlight the last bullet there. He says, which set of patterns are essential for students to help them learn how to think in patterns? So in his time, and again, Al is a consultant. He does training. You hire him to help teach you or fix your code or do stuff for you. So in years of trying to teach this stuff, he learned stuff, which is also true with Kent Beck. 5 years of trying to teach XP, he came away with certain things that he learned in trying to teach stuff. So next part down there is then he goes and talks about, oh yeah, so we've added some new chapters or clarified some stuff. We changed the order, you know, because he believes it's more helpful. And again, to learn the ideas behind patterns. So I'll call this out to Andrew as the most junior person on our team. When you understand these at that level, and very few people actually get there, it becomes like the cook, the master cook. I don't need a recipe. You want me to make something that tastes like Indian food? I know how to do that, right? If you only know, well, I know recipe 1, 2, and 3, you're limited to those things. If you actually understand how stuff works, you are not. Okay, so then he talks about, boom, back to why I picked this book. So down here he's talking about the journey of this, right? Where it's like you may have read, you want to do design pattern, but you find the literature too esoteric and a bit highfalutin. So this is the one I think, and again, when he, and I don't know how he approaches in the second edition for the first edition, but there's a whole part of the first edition book where he says, look, design patterns basically do these 2 basic things. Everything is a, you know, a variation of that. And then you can start to see, oh, there's a pattern behind how patterns are made, right? And it's a clear thing. And again, the Gang of 4 book is, it's a reference book, literally. It's not something to learn from as much as to refer to. So sometimes the language can be confusing. And my experience from the first one is it's much more clear to explain to you how that works. So this next bullet here I highlighted, when you understand the basic principles, you'll learn faster. Something that he talks about from what I've read so far in the new book is that design patterns don't exist in isolation, but they work together with each other, which he was talking a little bit in his thing. And the thing here that has happened actually for me personally, if you want to possibly discover patterns of your own, you're better equipped to make better programs. What I'll say from this is, I've been coding for a long time, and there's certain design patterns I came across independently, and those are the ones I know really well. I have built by hand, but I didn't call it the composite pattern several times in my career, so I know that pattern super well because I independently derived it based on the problems that we had to solve and wanting to have clean code. So for example, patterns like that, and no doubt those of you with a fair amount of experience may have independently stumbled upon some kind of pattern on your own. You'll read these books, oh, that's the name for this thing that I've been doing. And that's kind of good. And so this X part here, he really talks about, okay, he says to some extent, this is his journey of learning design patterns, right? And this one, I think, says learning patterns himself and the principle behind them. That's what he's saying was the first edition. You know, and you know, he's a professional consultant of some renown. So he even says before, hey, I consider myself to be reasonably expert in OO analysis and design, blah, blah, blah. He thought he knew this, but he didn't really understand the full capabilities, even though, you know, he was doing what people said. So there's a bit of history, which, you know, I'll try to sum through. Is like, ultimately, he found he wasn't taking full advantage of designing the interfaces, something he emphasized in the first book, we'll probably do in the second book. And of course, as Rubyist, less appropriate to us, but, you know, especially, you know, because examples are in Java, designing the interfaces can actually use interface, the Java construct there. But long story short, now he understands patterns better, he uses them better. He's got a little story about, you know, his background, something he had to help with, a project he was there to help, was sharp but new to OO design. And then he tried to approach the problem, and he did the way he'd been doing before, did abstraction, but it was not good enough. So, you know, spent 2 hours trying to use every technique that he wanted, but he couldn't come up with a better solution. A little bit of, you know, and this I give him kudos for saying sort of, hey, you know, people pay me lots of money for this, and I couldn't do this the way I knew. You know, wanted to take a break, couldn't help himself. So then he realized, oh, I don't have a single pattern, I use them together. And what I like about the new book is he intersperses these little sections, which as we hit chapter 1 are put in blocks for big summary points, which are nice for those of us with ADHD. says use them together. So this seems to be a big part of the book that was not in the first edition. So talks about patterns and reading Alexander's book, which of course is, everyone who knows anything about pattern in software knows that this is really the book that kind of drove all the guys that pioneered this stuff. But he looks there and he realizes, you don't create your class. Okay, so the part he calls out here is he does what you think is 00101. Create the classes, the problems, domain, stitch them together. And then he says, Alexander, of course, an architect, this is a bad idea. And of course, we don't question whether these are the right classes because they, quote unquote, seem so right, right? And that's kind of 00101. Take your nouns, making this, take your verbs, blah, blah, blah. Then he stepped together, used design patterns in Alexander's approach, and he came up with his far superior solution in just minutes. So he goes and talks about, this is great. And then he goes back to talking about learning and teaching, and this is where we change direction. It says, design pattern books you've been reading, they say you pretty much have to have a good grounding in OO design, which he's already saying, well, his knowledge of such is not as good as he thought. But after his own fact, and again, as his experiences as an educator, learning OO design concurrently with design patterns, let his students proceed faster than just studying them separately. So this is the point where Andrew gets to leapfrog us as the new guy. You get to learn it more effectively than we did, which for me is probably decades between learning OO AD and design patterns. So then he uses for his teaching, he calls that one. Here an example of making a problem with the bridge and having the students design a solution problem with a few guiding principles. This goes back to me in principle-oriented stuff, and this is actually, I'm exploring this approach in things that are not software at the moment there, but you get some people and you get them a problem, you give them some guiding principles and see what they discover. Well, amazingly, or not surprisingly, they discovered basically the bridge and implemented it. And so when I was talking earlier about, hey, you're going to understand this problem way better because you figured it out. And based on, what you had to work with, this was a solution was good. You'll remember that better than any kind of raw regurgitation of stuff. So then he's got this little sidebar here, design and XP, and he says, oh, these are clear to him now. They were stating the Gang of Four, but he didn't get it. Makes a mention Gang of Four was probably talking to Smalltalk, which understood these principles, and Alexander and Jim Coplian's work helped him understand it better. So he was trying. He's also an Agile consultant. So since he wrote the first edition, did a lot of Agile and XP coding practices, and he says he had a difficult time reconciling design patterns with XP and TDD, which makes sense because, in XP and TDD, you kind of organically move towards things, right? And I think a lot of people have the issue with big design up front versus evolving. But what I find ironic about this is Kent Beck is both pretty much the father of XP and TDD, as well as he's kind of the uncredited driver, him and Ward, of the whole pattern language thing altogether. And I had a bunch of references. He founded the Hillside Group, which pretty much led to pattern languages of programming and stuff like that. He's the first guy to mention Christopher Alexander. So all the Agile guys are also pattern guys, which can be some things to reconcile because coming from working in defense when I learned with design pattern, it's design patterns was like the holy grail for the big designer. Oh my God, you got all the answers here, And so your management there says, oh my God, you've got this book of patterns. Now you write perfect software. So they were done. And no surprise that DoD related stuff have a lot of emphasis on that one, though arguably they do it wrong per the whole principle. And again, refactoring the patterns kind of explains that also as well. So throughout the book, he talks about this. So I'm curious to see what he has to say on that matter. So in an event, guiding principle and strategy used to derive several designing patterns. And this is the part, I think, this is the real magic. if he explains this better now than he did in the first edition, I think this would be really valuable for you guys. So most then he talks about getting better. As you read the books, you'll learn patterns. That's important. Step one. Most people just kind of learn the names and rubber stamp them. But more importantly, you'll learn why they work and how they can work together, and principles and strategies upon which to rely. So, so this is a new way. I suppose I think this was always the right way. So that's Alan's preface part. His co-author has a different one, which I hide a little bit of thing, is he had come from a different experience. He started in AI. As he did a bunch of AI, he would see recurring themes. He would call these patterns. He came across Karen Gardner, who helped him a lot, and she realized, okay, this is, AI patterns of sort. And she did a lot there in Europe to extend this to OO system, and that's when he learned about basically the Hillside group and all the guys at Kempek and Eric Gamma learned, and so then he had a structure for this. Again, one of the strengths of patterns, really, communication. The beauty is you can say bridge, and this is a complicated solution to complicated issues that you can say in literally one word, right? So language, and this is always why I emphasize, there's so much education to be had, and I'm very disappointed with all the people I've interviewed, how little people learn stuff that is basically timeless. Like I pulled this book. This book is from 2005, and the first is 2002. I'm sure this is not dated, unlike How to Use Node, which is outdated the second it's written. This stuff is the timeless kind of stuff that every engineer could learn from. This is good. Patterns help end users understand systems because they provide context for the system, why we're doing things a certain way. Talks about that in principles, hooked. Okay, so then he talks about some conventions in the book, first place and scan, code examples, all worth reading, a little preface. Most of these books will say, hey, if you don't know Java, well, if you know C# or C++, this is how you. He's got a companion site for the book. We can check that out. Al will probably send me some other resources like he said he would. There's a summary again of what's new in the second edition, reordering, discussion about this one. So he apparently got a lot out of Jim Copian's commonality and variability analysis. But I believe he talked a bit about that in the first edition. He puts together extreme program design patterns. I have a great interest in that one. Code examples, more complete, has some other language there. I suggested in the last meeting that whoever, for the readers of various patterns, rewrite them in Ruby. That'll give us some value for us personally and probably will help the reader learn the pattern in question better. And, maybe we can send that back to Al for his site and say, look, there's examples of Ruby from the study group. So that's good. He calls the design pattern, you know what, Gang of Four never intended to name them all. They just picked 24, the ones they had at the time. This one acknowledges people. All right, so there you go. That's the preface. So I thought the preface was worth saying for all the reasons why I kind of picked this as the next book to do. Before we move forward, I want to know if anyone has any comments. Hopefully this will be a valuable way that hopefully really ups your ability. But I don't know. Okay, questions, comments? All right, well, everyone's still muted, so I'll say no. All right, so we'll go to the intro. And going through this one, in chapters 1 and 2, I want to go through fairly deep because he's trying to lay the ground foundation. And those of you who have achieved high skill in anything, software or not, realize that your foundational skills are always the most important. So I may adhere to this closer, I think, than we may on subsequent other chapters here. So I'll start off with his second paragraph. Because I will not follow the approach to the 80s. So I'm going to talk to you about OO, but and to some extent, this is the full knowledge of their object-oriented design. Find the nouns, no requirement statements, and make them objects. And then we say this is data hiding, but it is. And I think many people realize it's a limited view and incomplete. So he's going to discuss the OO paradigm with expanded concepts and examples here. Okay. So we start off kind of historically. We'll compare OO paradigm with previous one, structured programming. I suspect younger guys like Andrew have never even heard of structured programming, but that was the big thing before OO took that out of. And no surprise, the new one grew out of the need to meet challenges of the previous one. There are things that they couldn't solve right with that one, and I'll come down with some examples here. So the roadmap is he'll talk about functional decomposition, which is structured analysis here. He'll talk about problem requirements, need to deal with change, and I call this out. Extreme programming, Agile in general, is a development process focused on the fact that we know requirements are going to change, so we try to make that easier. Where waterfall is based on the reverse. If you lock it down, then you don't have to change, which we realize unless your cycle doesn't really work that well, or unless you've done it before. So he tries to describe OO and show it through examples. He'll call out special object methods common to OO development, and a little table. So that's handy. All right, so his first example is functional decomposition, a natural way to deal with complexity. So he's got this software problem where, okay, his task is, I've got to write code, access description of shapes at a certain database, and then describe them. So I might do it like this. Locate the list of shapes in the database, open up the list of shapes, sort the list according to some rules, display the individual shapes on the monitor. Right, and each one of these steps could be broken further. He takes an example of 4 and says, here's the 3 steps you can break on. All right, so the name of this technique is functional decomposition because the analyst decomposes the problem into functional steps, and make it up. So we do this naturally, and not even just software. It's the same approach you might do for making lasagna, making a bike, blah, blah, blah. This thing that you would tell, if you need someone to do you a favor. Oh, how do you do? Oh, well, just, open the closet, take this out, do that one. We determine, that's how we break things down if we break things down, as people. So, he's got these little his little cliff note. The problem with this, great power with responsibility. What happens is code like this, and this is the way when you first learn the code, you tend to write it, main program controls all its subprogram. The problem is the main program has too much responsibility, complicated code. It knows too much, right? So people learn this lesson, they figure out, oh, how do we fix it? We delegate, right? So what's the problem with? The problem is when the main program knows everything, doing change is hard, right? Functional decomposition doesn't help us prepare the code for the future, and those of us who have written programs that last a certain amount of time, we realize that is really important, right? The problem now is in such code, if we have change to the steps, we have to change a lot of code, right? So mistakes, constants here, he makes this comment, many bugs originate with changes to the code, for certain. If you don't TDD, almost certainly, which this itself is a little bit of, this is why you should TDD. All right, he says, verify for yourself, this has happened. Here's the fundamental problem with software requirements always change. I don't think for our group we have to delve in this. For guys who are not regular people, I should read this one. He loves to say that no one says, not only were our requirements complete, clear, and understandable, they laid out all the functionality we're going to need for the next 5 years. Yeah, no one ever said that, for certain there. So while we know requirements all change, very few coders write their code to handle this well. And this is our problem. This is why we go to OO. This is why we go to patterns. That's why we favor, when tools can give you ability to refactor stuff because it's hard. It's hard for certain. He suggests here, I may not know what will change, but I can guess where. He hopefully will elucidate that some. I know that when in the first edition we talked about design patterns, one of the things is take what changes from what doesn't change. And so then, because it'll change, it's easy to change those things. He calls this out, and I realize this was written in 2005. The environment in which software is developed changes. Who anticipated 5 years ago web development would be as today? Well, this is even farther now that we're talking 13 years after the second edition was written. So change happens, deal with it. Use modularity to isolate variation. So we're starting to get closer to the stuff that I think we will find key. You know, how do you write the code to make it more modular? Call the appropriate function. So in functional modularity, he has a pseudocode. The function is display state, takes in a type of shape description, action, switch. You can see this is the C-derived language, text, type of shape, case, square. The square is the function, square. So this is one step. Instead of having the code, we have functions here. So then if I have a requirement that changes now and I have a new shape, well then what do I have to add? Hopefully I only have to put another case shape below this section, right? But then there's some problems here, like, well, the inputs may not be enough now because it changed shape. So it's not just here, we may have to change what the input is, right? So modularity helps make it more understandable, easier to maintain, but doesn't deal with all the variations. All right, so those of you who have read this is probably the opposite of what you want. You want strong cohesion and loose coupling is the phrase that we say. Normally, this is the opposite. This is what happens. And he goes to talk about these a little bit below. So, Code Complete, a book we may study. He likes to use this definition of both cohesion and coupling. Cohesion refers to how closely operations in a routine are related. So I like L's statement here. He says, some people call this clarity because the more the operations are related to each other, the easier it is to understand things, right? And so then the opposite of this, which there's a book called Anti-Patterns, which is the first place that showed me what it's called a God object. But they call it the God object because it does everything. If you have this object does everything, there's no real organization. It's just, oh, I stuck it all in this bag, and now I have this bag full of stuff that does everything. It's better than it being all over the place, but it's not great, right? So, and this kind of goes back to the single responsibility principle, right? If everything is the single responsibility, there's a natural cohesion. These all belong here because they all deal with that responsibility. He didn't actually talk about coupling. Did he? Coupling. Oh, coupling refers to strength of connection between two routines. It's complement to cohesion, how strongly related to each other. In general, you want to be less coupled to specific things because it makes you hard to change. The last few examples in Pooter that we did kind of was showing, oh, I know this class now. I'm stuck to this class. What if I have a generic thing? Sandy was kind of trying to decouple some of those things, the concrete classes in our previous study group, and hopefully we saw the value of that last time. Yes, and so here's an example of why coupling is bad. Changing a function or data used can wreak havoc. If you're aware of these details, they cause problems to you, right? This one, this is the startling thing that I think experienced programs have changed a function or data somewhere and have unexpected impact on other parts of code. This is the experience that wins a lot of people over the TDD. You write some code, you run the whole suite, and these tests in some class, seemingly unrelated to what you did, start failing. When that happens, you go, oh my God, I learned in 2 seconds something that would have taken me weeks to debug. That's again, in my bias, I see, oh yes, this is the experience that brings you over to the value of TDD. But in this place, we're talking about coupling. This is what happens when you're coupled in ways you don't know. Right? Unwanted side effects. Hardest bugs to find and fix. Devil and side effects. Functional. Okay, so here's the problem with structure. Functional decomposition focuses on the wrong thing. Right? I'm focused primarily on the function. Changes to one function data might affect other functions. I'm curious to how the functional groups, and that's, a new contending force for the last decades, ironically. We'll address that one day. But okay, dealing with changing runs. So how do people do things? So now he's got a separate example. You're an instructor at a conference. The people in the class have another class to follow, yours, but you don't know where it's located. So one of your responsibilities is to make sure everyone knows how to get to the next class. So if we're doing structured programming, we're going to functionally decompose this. we'll do this. We'll get a list of people in the class. Yeah. For each person in the class, do the following. Find the next class he's taking, find the location, find the way to get there, tell them how to get there. So then we need the following procedures. Get the list of people, get the schedule for each person, the program, give direction from your classroom and in the classroom, control program, works for each person in class, right? Doubtful you follow this approach. So since apparently I'm into social commentary at all times, I'll put my little bit of micromanagement. If you were a micromanaging manager, you would do this. And for those of you who have not had the learning experience of having such a manager, this is the guy that tells you down to way lower detail because they have to control everything, right? Says, I would doubt you would like this. Except for micromanage, you would not to do this. You would do something more like, I've posted location of the classes is following in the back of the room. So use that to go. You'd expect everyone would know where their next class, what it was and where to go, and they would find it. So what's the difference this one? The first one, you give explicit directions to everyone. And we saw this in Tutor. Before she refactored out the classes, like the main program knew all the details. And as it got more complicated, it had to know more stuff, right? You have to pay a lot of attention to details, and you're responsible for everything. Right? In second cases, you give general instructions and expect each person will figure out how to do it individually, which I go. Shifting responsibility from yourself to individuals, which again, in my management social commentary, say delegate, assuming you trust your people, right? Shift to responsibility, this is good. And of course, as someone who's programmed for a while, I immediately see this as polymorphism, which I think I call out later. So you see the effect that reorganization, let's consider what happens when new requirements happen, right? So now I need to give special instructions for graduate students who are helping. Right, maybe they need course evaluations, take them to conference class. In the first case, I have to modify the control program and give special instructions. It's possible I'd have to modify the program considerably. So you want to minimize change. So, you know. Second case, people are responsible for themselves. I would just have an additional routine for the graduate students to follow. So I could still say, go to your next class. And each person would follow the instructions appropriate for themselves. Okay, and again, you know, for those, especially after we just did the last one, you say, oh yes, polymorphism. Graduate student dot go to class versus, you know, undergrad dot go to class, right? Shift in responsibility from the control program. You know, every time a new category. In the old way, you had to modify it, but you don't. And again, this is exactly the bike thing where I had like different preparation things, and I didn't have to know how they prepared it, just that they prepared stuff. So. You know, people responsible. Well, how does this work for their own behavior? Control program talks to different people as if they were the same, which of course calls out polymorphism, which I believe Al calls out another few pages down there. So I don't need to know anything because I just call the one method. Different perspectives. Okay, so then he's going to call Fowler's different perspectives from UML distilled. He's got three here. Conceptual. This is the concepts in the domain. And basically, what am I responsible for, right? Doesn't care about the implementation of how the software works, but what needs to happen, the concepts. Conceptually, what needs to happen. Specification, so now you look at software and you look at the interfaces. And again, in statically typed languages, this becomes really important because those are harder to change in duct-taking languages. The actual implementation is, okay, now how do we actually do it? How do I fulfill the responsibilities that were conceived of here and specified here, right? And he definitely talks about it below, that this is pretty much the only level most programmers are used to dealing with. So we go to here. So like example, go to your next class, right? The instructor is saying the conceptual level. What? The instructor just goes, this is the level the instructor needs to know. You know, you tell people what you want, not how to do it. I call it again, law of Demeter, you know, or tell, don't ask from the pragmatic programmer. You know, commuting at one level conceptually, while performing another level results in the requester not knowing exactly what is happening. And this is the benefit of decoupling. Just conceptually know what's happening, very powerful. Use of object shifts responsibility to a more local level. Right, okay. So then he breaks down, okay, what is the responsibilities of the conceptual? The student knows where his classroom is, which classroom to go to next, how to get from one. Another instructor needs to know what, to be able to tell them to go to the classroom, he's expanded the domain model a bit, where the classroom has a location, direction giver. This would be your maps, Google Maps for classrooms. Having 2 classrooms, give direction from one to the other, right? This one, we identify the objects by looking at the entities in the domain and what they needed to do. So this is consistent with finding objects in the nouns and then finding the method looking for verbs. You'll see that as it gets complicated, this is not enough, but it's a way to get started. So at this point, we've come to circle where, okay, this is kind of AD 101, nouns and verbs, with a little explanation of, okay, let's look at what are nouns and what the responsibilities are. Slightly different than just verbs, because it tells you where to put the verbs. The best way to think of an object is think about something with responsibilities. Or we can use Fowler's perspective. Conceptual level, a object is set of responsibilities, specifications are separate methods. This is kind of abstract versus concrete. Implementation is the actual detail here. And we had a little bit of abstract concrete in the last one that I think, outside of specific terms when we deal with object-oriented programming languages. Okay, so OOADs only typically talk about implementation level, codes and data, whether conceptual and specification, but there's a lot of strength to that one. Objects have interfaces for other languages to use, yes. Okay, so then organize objects around the class. So now he's going to back introduce what the idea of a class is. So it would be inefficient for each student object to have its own set of methods, right? And to some extent, if you couldn't reuse prototypes in prototype-based languages, that would be this. I'll have to write the method for each guy. Well, it's kind of crazy because apparently there's a set of methods that are in common, right? And so then he finds out, well, there's some things where there's common data objects and common methods and how they're accessed, and this is the class, right? Objects are instances of classes. So we can see students where I might have 3 students. They all have different classes, but they have the same responsibilities, the same data. Scott and I may take different classes. We may have English and archaeology. I might be taking calculus and psychology. We're different people, but we're members of the same class, right? So then we tell new object of this class, so an instance. So this is just a detail, instantiate objects of classes, work with objects in the example. So now he tries to break it down. This is how you might code it. Start control program, instantiate the collection of students in the class, tell the collection to have the students go to their class. The collection goes around and tells each student to go to their class. Each student finds out where the next class is, determine where it goes, done. Right, so you need an abstract type. He's talking about this is fine until he has a new student type, graduate student. Right, so he kind of breaks this down to regular student versus graduate student. So what is the parent of which these are 2 variations of? We'll make a student called the abstract class, which arguably he's based on what do the classes do. It's the interface that we follow, which of course in Java we could actually have an interface. You can also, if not mistaken, you can also, it's been a long time to program a significant amount of Java. Abstract classes. If you can't do it in Java, you do that in C++. C++ certainly has abstract classes. So he talks about define what other classes can do. This is really the interface. So a concrete class, he's saying, represents a specific non-changing implementation of the concept. So you have the concept in the parent class and the specific implementation of these, of which you can have common implementation at this level and just override specific at these lower levels. So he pretty much says that. Next sentence, and the type of relationship between this is ISA. So we have ISA versus HASA, and we should talk about that in great depth because one of the things design patterns do is they favor encapsulation over inheritance where possible. So we will talk about both kinds later. Going the other way, the base class generalizes is a superclass of these things. So placeholder for the class, I think these members of this group understand a fair idea what classes are. So the beauty is the program can deal with students. And you get type checking of students for those who have type checking, and each kind of student is left to their own concrete class. He does say, is there more than classes that don't get instantiated? They define the abstract level at the conceptual level, which in my mind is the non-programming version of the interface. This is the interface to this class of things, which is sometimes confused by Java people because there's actually the keyword interface there. Visibility, so this is 0101. There's 3 basic kinds of visibility in programming languages: public, everyone can be seen; protected, only the class and derived objects can see this. I should note that in Ruby, protected is slightly different than other protected. Private is only objects in that class can see it, so even your subclasses cannot see that one. Encapsulation, that's another buzzword. Oh, shoot. Okay, it's 11. Let me see how many pages I have. Should I wrap this up? Can I wrap this up? Okay. I kind of want to do the full thing because I think it's important that we start with a good foundation. So it's 11:01. I'm going to wrap up the hour and switch it to questions, and then I guess I'll pick up with this next week. Any questions or comments on what I said? Is that okay? I realize in my typical speak 100 words a minute fashion, I probably went pretty quickly. Was that okay, clear, too pedantic?
It was beneficial.
Right.
It is 2 o'clock.
Yeah. So any questions, Dom, Sam? Diego want to bust my chops or anything?
Diego is defense. I am happy. I like the chapter. His writing style is nice. It's a little bit different.
Okay. Well, if no one's got any questions, I'll pick up. We should do chapter 2. I'm willing to do chapter 2, unless someone wants someone who talks less fast to do it. If someone else wants to do chapter 2, I'm okay. Otherwise, I'm okay with doing it. You, of course, will get my social commentary interspersed, which you may or may not want. Scott, we'll do chapter 2. Okay, so all right. So then, okay. So next session, I'll finish the last 5 or 6 pages of this, and Scott can pick up chapter 2. We'll pick up then. If there are any other comments, questions, I'm glad Al gave us some insights, and I'll probably be in contact with him in general. I've been kind of discussing Agile adoption issues on Twitter with him today. So, okay, well, thank you for coming to Nested Loops. I hope you enjoyed it. See you next time. See ya.